So, 6h. And you can put this as y now that you've got it straightened out, because some people like to put this as y because you're talking about dy dx, so you could actually do that. That's not a big deal. 6y is equal to 15y minus 15x. I'm going to solve for y, so I'm going to bring this over here. So that means 0 is equal to 15y minus 6y. I don't know where 9 came from. 6y minus 15x. And of course 15x come over. So 15x is equal to, no sneezing either. 15y minus 6y is what? Huh? 9. Divide by 9. And y is equal to, dang old 5 what? 5/3? I'll take the derivative of that. In respect to what? Okay, that's not rhetorical. In respect to t. Always in respect to t. So dt of y is equal to 5/3 x. So what's the derivative of y in respect to t? 1 dy dt. Because the derivative of y is 1. And then dy dt equals 5/3. Derivative of 5/3 x is 5/3 times what? What is dx dt? 7 feet per second. So it looks like to me, plug in what? Plug and chug, because you want to know dy dt. Is equal to 5/3 times 7/1, which is equal to 35/3, which is equal to 11 2/3, 11.67. Somebody check my math. Feet per second.
These problems are always going to be like the triangles.
Pretty much.
I thought that d y dt is negative, usually negative, ain't
Okay, what kind of problem was that?
it? I don't know.
Come on.
One that we did,
What kind of problem?
a math problem.
No. What kind of problem was it? What was the subject in the problem? What was leaning up against the wall?
A ladder
Okay, and the ladder was going
down.
down.
What does this do?
The same ladder. Now come on.
I mean,
Okay, all right,
it's a
here we
triangle,
go.
they're
We got
all
a guy's head right here and a lamp, so we're going to draw a line here, and that's going to be a ladder, and it's going to fall down.
I mean, they're
Okay.
triangles.
Bridge, hold up cars. Got to be strong. Got common sense here, okay? All right. What have we got here? 15 feet. We got 15 feet right here. All right. This guy is walking away. He's walking away like that. All right, at 7 feet per second. The question says, at what rate is the tip of his shadow, right here, what rate is it moving when he's walking away? Now, what did I just tell you about y? I told you that y in this case is going to be h. Okay, now after I got this set up, I changed h back to what? Y. Now you can change it to h if you want to, and this would be d of dt of h is equal to 5/3, and then this would be dh dt, and then h would be horizontal distance. You could do that. But the reason I did y is because you're all used to dealing with y.
So that's the answer?
Yeah, that's the answer for the first part. Okay? In other words, right here, you got to think, what is this guy doing? This guy's moving this way, and this shadow, think about it. Is it getting, when he's right here, that shadow is what? It's going to be longer, right? And he's going to move like this. This shadow is going to get what? Slower and slower, or what? It's not going to get longer and longer as he moves out, because the shadow is dependent upon this guy right here. Okay? And as he moves out, out, and out like that, you just got to think. Okay, there's the tip of your shadow. Right there. Okay? As this guy's moving, this thing's moving that way. Okay? Before, you had a ladder, and as this moved this way, this was moving what? This way. Okay, now you've got this moving this way and this moving this way. So they're both going to be what? Positive. Or this is going to be negative. Ladder. That's the kind of problem. Okay? That's what I was asking for. All right, do the second part. Set it up. I'll give you a hint. You're going to use dy dt and dx dt. So that would be, when you set this up, dang old changing, dang old be y minus x, or h minus x. So that would be the derivative in respect to time of y minus x. Let me take a minute and erase this. Really? So part B, way that you set it with the changing is delta, right? Change in y or the change of x. What's that? That's delta y over delta x. So changing would be delta, which would be d over dt of y minus x, which is this right here. So that's going to be d dt of y minus d dt of what? X, which is going to be dy dt minus what? Dx dt. Now write this down, because whenever they're asking for change, this is what you're going to do. When it's along the same axis, of course. Right, Miss Anthony? Not linked against the wall. This is all along the what? Sidewall. So that's going to be dy dt minus dx dt. So that's some hard math. What's that going to be? Well, dy dt is what? 11.67, right? So 11.67 minus what? Think y'all can handle that? I think that'd be 4.67. So that should be your answer. And let's see what they got. "35 thirds and 14 thirds. Somebody do the math and see what you get. Huh?
We had 35 thirds.
So we should get,
We had what?
35 thirds for the first year.
Yeah. See what, it's 35 thirds, 11.67?
Yeah, that's what I'm saying. We had that.
That's what I was asking. That's what I was asking. Oh, yes, that's all that. So don't make it complicated, okay? And 14 thirds, divide 3 into 14, you should get 4.67. Can't do another problem with these. How do you do another problem? Supposed to let you do another problem. How do
they
you do
don't
it?
always give you the option to do that.
Well, that's nice, isn't it?
Practice another version.
Practice another version. All right, you do this one. Hold on, let me blow it up. Miss Anthony, I am going to ask you to show us how to do this one.
Please don't make me do that.
I did that. I told you about that, right?
Yeah, but I'm
That
not.
student
I'm
came
not
up here.
acting like I know what I'm doing. I really don't know what I'm doing.
Oh, this guy, he got up there and started stuttering. His gray shirt turned dark gray, color of his sweatshirt. I mean, it was a light gray sweatshirt. By the time he got through, it was soaking wet. He was stuttering,
I invented calculus. You want me to come up here and show you class?
You invented it? Okay, yeah. Come on up here.
I just need to refresh it up.
Okay. Now, this is a test question. It will be 2 or 3 test questions, so make sure you know how to do it. It'll be on the online test, and it'll be on the in-class. And I am grading your in-class. I'm having to grade all of them, so not just this class. I have 4 other classes I'm having to grade. So stupid.
So you're going to have to give an in-class test for everything now?
In this class, yeah, I have to give y'all an in-class test. In calculus, you have to have all in-class tests. So what I'm doing is giving y'all an in-class test and giving y'all home class. I'm using the in-class test for another grade. I'm putting them all together.
Oh, you're actually using the in-class test for it, right?
Yeah, I have to.
How
That
do-
way y'all will say, when you go to another calculus class, yeah, he did an in-class test.
Oh, it's just bullshit on the first in-class test.
No, they
Oh,
have to
man,
be
I
graded.
Zero on that. Like, I know
I'm
I-
sorry.
Oh, man.
I told you I would make it easy,
You said.
but I
the
didn't. I
online
have to
test-
give y'all, don't
You
even
said
go
the
there.
online test
Don't
is
even
gonna
go
take
there.
that spot.
No, I didn't say that.
Yes, you
Yeah,
did.
you said you'll take the highest of whichever.
See?
Okay,
That's verbatim.
okay. I didn't know I said that.
Because he wanted to Mickey Mouse it or somebody.
Oh, okay. Mr. Brooks, be quiet.
So the whole first part should be the exact same, right?
Pretty much, yeah.
So we should just put the numbers into the second.
Yep. Since I had to blow this up so big. Okay, today's eraser day. So, span 6 feet. Walks at a rate. Let's see, he's going. $15 feet. So, this distance right here is H. And you can say this distance right here is H minus X. No, you can say this is X. Or H minus X, either one. Or, no, I'm sorry, H minus X. And this is X. Or you can make this X, yeah. H minus X here. Minus X. So that's gonna be 15 is to 6, as H is to H minus X. So that's gonna be 6H is equal to 15 times H minus X. 6H is equal to 15H minus 15X. And bring over the 6H across the river. Bring the 15X across the river. And that's going to be 15X is equal to 9H. And then divide by 9. And 15, again, we get 5/3. What changes?
When you times it by, you don't times it by 7, you times it by.
Oh, they changed those, okay, they changed this number. Okay, so now we're gonna take, this is finding our, this is right here, 1, finding the related rate using our, and this is basically similar what? Okay, similar triangle. This is what you're gonna be using. Hold on a second. Okay, just forget it. I'll show you in just a minute. Related rate. Set up your related rate. Now, once you set up your related rate, which is right here, go over here and you say, okay, I found my related rate. Now that I found my related rate, I'm going to take the derivative of it in terms of what? should be 5/3 x. So now I take my derivative of my formula or my equation in terms of time, and that's going to be 1 dy dt is equal to 5/3 dx dt. And once you take the derivative, then it's just plug and what? Plug and chug. Start to see a pattern with them. Start to see a pattern with the ladder, and with these type questions, the same thing. And once you get plug and chug, you take this guy, and that's going to be dy dt is equal to 5/3 times 8/1, which is equal to 40/3, which is equal to 13.33 feet per second. And then with B, part B, you're finding delta, which means the change in y minus x, which is going to be dy dx minus dt, dy dt minus dx dt, which in this case is going to be 13.33 minus 8. And I have no idea what 8 minus 13 minus 8 is what? I'm sorry, what? 5.33 feet per second. What happens when you plug in a decimal? Does it like it or hate it? Okay, it says integer. Okay, it says decimal. So the first one is 13.33. Stupid computer. And 5.33. And it says we're stupid. What did it just say? Somebody tell me what the direction said when I put it on here. It said type in an integer, a fraction, or a what? It said a decimal, did it not? Gods. They're all gods. They're gods. All right, let's do another one. I mean, not this one. Let's do another problem. How do I get out of this?
Close it down at the top. Just drag it up.
Yeah, but if I close it down, there. Okay, thank you. I'll make sure I didn't get out of everything else. All right, let's try this one. A street light is mounted at the top of the. Is this the same type? Is this the same one? No, it's a little bit different. Well, go ahead and do it. It's a little bit different, and it helps you to do different ones, and then we'll do the boat problem. A street light is mounted at the top of a 15-foot pole, man is 6 feet away, walking at 4 feet. How fast is the tip moving 50 feet from the pole? I'll cut and paste this out. one's a little bit different. What's different about it? Yeah, but I'm talking about the setup. Well, they're giving you an end result of 50 feet, so it'd be not X minus Y, but X what? Plus Y, because it's the total length, so it's going to be X plus Y. That's the only difference. At 10 feet was less, so it was X minus Y. So 50 feet is at the end, a longer distance, so it'd be X plus Y. That's the difference. So, what's that going to be? 15y is equal to 6 times x plus y. And 15y is equal to 6x plus 6y. 6y goes across the river, and that gives you 9y is equal to 6x, and y is equal to 6 ninths x, which is 2/3. So there's 1. 2 is take derivative in respects to t of your equation. And that's going to be d dt of y equals 2/3 x, which is going to give you dy dt is equal to 2/3 dx dt, in which dx dt is what? So that's going to be plug and chug. Plug and chug would be 2/3 times 4/1, which is equal to 8/3, which is equal to what? 2 and 2.67. feet per second. Now, what I was going to show you is when you were dealing with a conic tank, and you'll get this next semester, but this is what you're trying to get ready. You got a conic tank, and you got, remember the push-up I told you about? When you have a push-up, you have a stick right here, and that stick has a little plastic plunger right there. Pushes the ice cream up. Well, you've got a plunger right here.